All right, we're going to get started with our 4-2 notes. Listen, we're going to get started with our 4-2 notes. Grab a packet, put your name on the front. Today is the 16th. Once you've got your name on the front, in the middle of your tables, you'll find a sheet of graph stickers. You're going to have to grab a ruler, get your name on the front of this. Put your, there you go, pencils in hand. Now, everybody at the table, turn your packet over once your name is on it. And I want everybody at the table to take a graph sticker, put it on the back of your packet. Ladies and gentlemen, you need to stop talking and listen. My video is started. Our lesson is happening up here today. You'll have access to it later. On the graph sticker on the back, I want you to draw an XY axis with your pencil. We'll get into using some colors in a few moments. With your pencil, I want you to draw an X and Y axis. At this point, these things need to happen without talking. Once you've got your X and Y axis on the back, we're going to move to rotating and using different colors. And part of what we're going to be doing, so what we're dealing with in section 4.2 is reflections. And with the reflections that we're going to perform, now reflections are, creating mirror images by, sometimes people think about reflections as flips, like you flip it over a particular line. I just want to remind you that the horizontal axis is the x-axis. If it's going on my notes, it needs to be going on yours. Oftentimes we'll be faced with creating a reflection over the x-axis or y-axis. So what I'm going to do on the back side here, what we've got going on is just a presentation of different common lines of reflection and things that you guys are going to have to use in order to perform reflections in the coordinate plane. So one of the things, we know that this is the y-axis and the x-axis. With one color marker, and I don't care what it is, we're going to graph our first equation is going to be y equals x. Our first equation, so we're going to write the equation down in color and then we're going to put that on our graph in the same color. And if y equals x, the line is going to go through the origin when 0 is equal to 0. Y equals x, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, negative 1, negative 1, negative 2, negative 2. Y equals x is kind of, sometimes people like to talk about it as the diagonal line through the coordinate plane. So our y equals x line needs to be graphed. So you guys are going to look back at this for some of your homework problems and quiz questions to come and get familiar with these lines, because once we get to final test in chapter 4, you'll be reflecting figures over all the different lines that I'm presenting with presenting for you. Just like the y equals x line is a common one for graphing, for reflections, I'm going to put another one on here, and it is y equals negative x, the opposite of x. And this, so I picked up a new color, and y equals negative x is going to be negative 1 and positive 1, negative 2 and positive 2, where your x and y pairs are opposites of each other. And that is going to be the diagonal going this other way. You'll definitely be recreating these lines. I'm actually going to go and write on them what they are. Y equals negative x. I'm going to go back and pick up my color, y equals x. I'm going to write them on there as well. This is my first one. This is my second one. These are going to be common lines of reflection that you guys will be creating on your own, and you can look back at this for an example of what they are. Again, x-axis and y-axis are going to be, x-axis and y-axis are also going to be common ones that we're asked to reflect over. Now the third one that I'm going to put on here is going to be an example of a horizontal line. Now, and I'm going to put example of a horizontal line, because horizontal lines always have an equation that is y equals some number. Now, in a horizontal line, so my example, let me put on here y equals 5. When we have to graph a horizontal line, all we do is go to the y-axis all we do is go to the y-axis at 5. And the thing about a horizontal line is no matter what the x value is, like in this case, the y value is always 5. So this will be horizontal line through the y-axis at 5. If it was y equals -3, it'd be a horizontal line through -3. If it was y equals 100, it'd be a horizontal line through 100 on the y-axis. So y equals 5. So your horizontal lines, and then I'm going to go to verticals. Your horizontal lines and verticals could be anything. You just have to pick up on horizontal is a y equals, and then vertical is actually going to be, what do you think it's going to be if horizontal is y equals? When we think about verticals, horizontal or y equals, what do you guys think verticals are going to look like? Yeah, not saying it very loud, but verticals are all going to be x equals all the time, because the x value would be the same all the time. Let's put an example of, oh, I didn't put my 3 here for this graph. That's my third one. Let me reiterate that the reason I'm doing this is because you guys are going to need these examples of how to draw the lines that you're reflecting across. A vertical line is going to be an x equals, let's drop in x equals -3. So I'd go to the x-axis at -3, and it doesn't matter if I go up or down, no matter what, x is always -3. Every single every single vertical line is going to be an x equals equation. Every single vertical line is going to be an x equals equation. So we're dealing with reflections in section 4.2. Yesterday we were looking at translations, those slides. So the thing about reflections that's going to be different is the orientation of our figure is going to change because it's going to flip over a line of reflection. The orientation of our reflections are going to change because they flip over a line of reflection. And then one of the nice things that you'll get into in your packet, besides this as a resource, within your 4.2 notes packet, you guys will see, within the 4.2 notes packet, you guys will see in the core concepts, this is the second page in, it shows you exactly how the points change as you go over certain lines. It tells you how the XY points are transformed as you go over certain lines. So you'll look for that in your packet. I'm going to move along here. If you're not finished with all your graphs, you can look over at your neighbor and whatnot. I see a lot of people at tables kind of sitting and chilling. I know some of you are still drawing. Look over at your neighbor if you're still trying to get caught up on that. And then I want you to find this place in your, notes packet. Now, we're going to work with, I want you guys to have your pencil handy, and then we'll perform all of our reflections with a color. But I want you to start out for every pre-image with your pencil handy, and then we'll start this by, this grid only goes to 4, but they want us to go to 5. You know what? I'm going to act like it goes to 5, you guys. I don't want to go by 2s. I really don't. Well, yeah, I could, but you know what? I don't want to go by 2s. I want this to go up by 1. If I'm going to put point A, then that's going to drop point A up here. Just put it right up above where it would be at -1.5. These are all going to start out as triangles. I want you to put your pre-images in pencil. Find where the extra practice is. We're going to roll the same way that we did yesterday. We're going to go through this work together. And then you guys are going to get into reading and creating your definitions, putting those definitions in your own words. But I think after we talk here, you're going to have a much better sense about what the things mean. So I'm plotting my A, my B, and now I've got to still put my C on. So this triangle sitting right here. And I'm just going to, again, I'm in pencil. There we go. And I just shaded it in a little bit. That's my pre-image. Starting out with this triangle ABC as my pre-image. Now, my pre-image has to be, now I'm going to pick up a color, and the line of reflection it wants me to go over is the y-axis. So I like reflections because when you're in the coordinate plane, like take a look at where A sits, and A is 1 unit to the left of the y-axis. So if I'm going to flip over the y-axis, I'm going to stick A prime at 1 unit right of the y-axis. Go ahead.
So when you reflecting over axis, would you just change, like we're saying over the x and y axis, would you just change the y value to like just make it the opposite?
I don't think it's the y values that change. Think about this as we're drawing it. What is it that's changing? Because y value has to do with how high it is, and it's staying at the same height. What's changing? Your x's are changing. Yeah, so when you go over the y-axis, your xy becomes negative x, positive y. So if you're not in the coordinate plane, you can still write out what the coordinates would be going over the y-axis. This is the rule, and if you look above this, you'll see the coordinate rules for reflections. Above these extra practice problems, you'll see core concepts, coordinate rules for reflections, and that's the one that we just, y-axis was taking the opposite of the x value and leaving the y value or the height the same. So when I move over to number 2, just to get thinking about what's going to happen, bless you, this time I'm going to go over the x-axis. And when I went over the y, it was the x that changed. When I go over the x-axis, it's going to be the y that changes. We're going to do the opposite of the y. But the first thing that I've got to do is plot out what my pre-image is. So 0, 2 is where A sits. 4 and 5, I'm putting it up here off the grid. I don't care. We can still flip it. That's where the B sits. I don't know why I wrote B prime. And then 5 and 2 is where the C sits. And that would be sitting just right outside here. So my pre-image now is this triangle. And this time I'm going over this axis. My pre-image is this triangle, but this time I'm going over the x-axis. Now our y values change. The height of the figure changes, and height has to do with the y values. So I think about these like, okay, so A is sitting 2 units above. When I reflect it over the x-axis, it's going to be 2 units below. C was 2 units above. I'm going to reflect it and put it 2 units below. Did you guys grab a color to do your reflection? 2, 3, 4, 5. B is 5 units above. B is going to go to 5 units below. So my image, A prime, B prime, C prime, is going to look like that. Just taking a moment so everybody can catch up on that one. And anybody that's looking ahead, what is y equals? What kind of equation is y equals? We can look back. Y equals, is it horizontal or vertical? Take a look at the back of your notes. Y equals is going to be a vertical line, yeah. So if you're ready to move forward, what you're going to do then is grab your pencil. Let's plot number 3's A, B, and C, 2 and -1, -4 and -2, and -1, -3. And then I'm not picking up a ruler for these just because the grid is so little. I'm just kind of sketching it. So shading in pencil what my pre-image is. Now in this case, now I've got to go on and I've got to do it over the y equals 1 line. So I have to go draw this y equals 1 line in. It's not the x-axis or the y-axis. It's the horizontal line through 1 on the y-axis. Horizontal through 1 on the y-axis. And we're not going to have any distinct rules. I know, Dominique, you were getting at that. Like, are we going to have a rule about what changes? When we're going over horizontal and vertical lines, it's going to be a matter of counting, and we're not going to be describing our XY pairs. I'm not going to require you guys to describe your XY pairs like we did with these. When our lines are vertical and horizontal and not the XY axis, we're not going to do descriptions this way. Once you've got your colored y equals 1 line on there, how far away are these points? A is 2 units below my line. A prime's going to sit 2 units above my line. So now it's just my line that distinguishes where I count to and from in order to draw this. B was 3 units below. I'm going to move it to 3 units above. C was 4 units below this line. It's going to go up above the grid to 4 units above the line. No. I'm sorry. If it's y equals, your x value stays the same, but I'm not willing to put a rule on what y is. That's what I was just saying. When we're in lines that aren't the y-axis or the x-axis, we're not going to be writing these rules or required to. You'll perform it in the grid. Your x values will change, but it's not a simple change because it's not the... I'm sorry, your y values will change, but it's not a simple change because it's not over the x-axis. It's over a line above the x-axis. Now, I'm going to move on to number 4. And in number 4, we're looking at an x equals equation. Just graphed in that color. We're looking at an x equals equation. And so this is going to be a vertical line through -3 on the x-axis. So maybe I just put that one on here first, right here, through -3. So that's the line of reflection I have to go over. Oh, this ain't going to be pretty at all. Uh-oh. -2, well, we'll see. Let me put it in pencil. -2 and 3 is A. I think we can sketch it over there. -2, -2, she says, okay. Yeah, I think, oh, we can sketch it over there. This isn't as bad as I thought it might be. What's the only point that's going to go off the grid that we're using? C. Yeah, C is going to be the only point that goes off grid. C will be the only point that goes off grid. -2, 3. -2, -2, 0, -2. There we go. So my vertical line, why did I put a prime on A? Good question. So A is 1 unit to the right. A prime is going to be over here. B prime. C prime is going to be over here.